Hello, my little mathematicians. Let's go ahead and finish wrapping up this decimal study guide. So if we take a look at number 21, it says a water tank was leaking 2.3 gallons of water per minute. It took the repairman 15.2 minutes to stop the leak. How many gallons of water were wasted? One thing, a lot of times when you see word problems and they're confusing numbers, you're just kind of stuck and you don't know what to do. So, a wise suggestion would be to make the numbers simpler. For instance, let's look at what if the water tank, instead of leaking 2.3 gallons, what if it was instead just leaking 2 gallons of water per minute? So, every 1 minute. Okay. And then it took the repairman 15 minutes to stop the leak. I just like even numbers. So let's say it took 16 minutes to stop. So then how many gallons would be wasted? Okay. What do you think? Well, in 1 minute, how much is wasted? Yeah, 2 gallons. Okay. So then after 2 minutes, how much is wasted? Another two, right? And after another minute, how many is wasted? Another two. So you're going up each time. And a lot of you already are like, yeah, it's 32. I already see the answer. And it's like, okay. So if you keep adding in increments of two every 1 minute, your brain is so smart. It's like, yeah, you 32 gallons are going to be wasted. How did you get that answer? You took this 2 and 16 and multiplied to get to 32, right? If you just make the numbers a lot simpler, a lot of times your brain is so smart it figures out the answer. So take a step back and be like, okay, I know that it's going to be 32 gallons wasted. What did I do with these two numbers to get 32? And then you'll be like, oh, I just multiplied them. Okay, great. So now instead of using this 2 and 16, why don't we use the numbers from the problem right here of 15.2 and 2.3? And I'm going to multiply those instead, and then that's going to give me the answer. That's a huge test taking strategy, is just make the numbers simpler. And then most of the time, like either reason it out, or a lot of times you just figure out right away. And then once you get that answer, take a step back. What operation did you do to get it? Now do that same operation, but with these harder numbers. Okay, remember when you're multiplying, you don't need to line up the decimals. They just happen to be lined up in this problem. And you just multiply like normal. So 2 times 3 is 6. 3 times 5 is 15. Carry the 1. 3 times 1 is 3. Plus 1 is 4. And now that's all used up. So I want to move on to the tens place. So I need to put a 0 placement holder. And 2 times 2 is 4. 2 times 5 is 10. 2 times 1 is 2. Plus 1 is 3. Now I add down. So I have 6, 9, 4, and 3. You multiply like normal. The only thing is, for your final answer, however many numbers you had up here after the decimal, so 1 there and 1 there, I need a total of 2 numbers after the decimal in my answer. So it should be 34.96 gallons were wasted. All right, let's take a look at the next one. The next one says a marathon runner was running at a rate of 9.3 miles per hour. At that rate, how many hours will it take for the runner to run 26.2 miles? If you need to, round your answer to the nearest hundredth. Okay, so let's just make these a lot easier. Let's instead say, okay, they go, say he runs 10 miles per hour, okay? And then we want to know how long would it take him to go 20 miles? Okay, what do you think? A lot of you already figured it out. Yeah, you get 2, right? Because if in 1 hour he can go 10 miles, after how many hours is it going to take him to go 20? Okay, so 10 in the first hour, and then another 10. Oh, look, he's already at 20, and that took a total of 2 hours. So we know that the answer is going to be 2 hours in order to complete that 20 miles. What did you do with this 10 and 20 in order to get 2? Yeah, you divide it. 20 divided by 10 is 2. So now let's do it with the numbers here. Instead of running 20 miles, we want to run 26.2 miles. Instead of running 10 miles per hour, they ran at a rate of 9.3 miles per hour. Now, the only thing is when we're dividing, we can't divide with decimals. So I need to move it over in the divisor. And however many times I move it in the divisor, I need to move it that same amount in the dividend. So now you have 93 into 262. Well, can 93 go into 2? Nope. Can 93 go into 26? Nope. But it can go into 262. How many times? Yep, twice. So that's 6 and 18. Subtract that. And remember, you can always pause the video and then unpause it and come back and check. Okay, you should have gotten 76 left over, and then there's nothing else to bring down. So let's just add a decimal and a 0 because 262 is the same as 262.0. So now I can just bring that number down, and now I can do 93 into 760. 9 goes into 76 8 times, so hopefully let's see if 8 works. Not, we can just go smaller. 74, 72, 74. Okay, it worked. Subtract that, and you get 16 left over, which is less than 93. So we're good to bring down another number. And 93 goes into 160 once. Subtract that, and you get 67, which is less than 93. So good to keep going. Bring down another 0. 9 goes into 67 about 7 times. Let's see if that works. 63, so plus 2 is 65. And borrow. Okay, 19 left over, so you'd bring down another 0. But notice how it said round to the nearest hundredth if needed. Always look at those directions. I don't need to keep going and going and going. The hundredth is how many places out? 2 places out. So I only need to go 1 further than that, which I already have. So I need to ask myself, it's 2.8. Does that stay a 1 or go up to a 2? Well, that 7 tells it to bump up to a 2. Okay, so it's 2.82 hours that it's going to take me to go 26.2 miles if I run at a rate of 9.3 miles per hour. All right, hopefully you did pretty well. Again, remember, always pause the video, try it yourself, and then unpause it to join us and see how you did. For this next section, we're going to try to estimate these numbers. When we say estimate, round it to a whole number first and then just add those whole numbers. So 5.2, what would you round that to? Yeah, that's about 5. The 2 says stay at 5. For 1.9872, that 9 tells this to bump up to a 2. So what's 5 plus 2? 7. Okay, 12.8, what would that round to? 12. And 4.792 would round to, you're right, 5. And what is 12 plus 5? 17. Okay, 15.2978. Again, pause it and try it yourself first. Okay, hopefully you put 15. What did you round this to? 100. And when you add those together, you got a final answer of 115. Okay, the next one, what would you round this to? 16. And what did you round that to? Yeah, that 8 tells us to bump up to a 4. And what is 16 minus 4? You got it, 12. What'd you round this one to? That 6 tells 8 to round up to a 9 minus, what did you get here? Yeah, that 7 told the 3 to round up to a 4, and 9 minus 4 is 5. Okay, final problem. 23.9102, that 9 told this to round up to a 24, minus, and this is just a 3, right? The 1 says stay at 3. And 24 minus 3 is, you guessed it, 21. Okay, and that's what we're going to do when we're estimating. Okay, use your rules of rounding. If the number behind the one you're focusing on, which when we're estimating, just round to the nearest whole number, if this one is 4 or below, it tells this to stay whatever it is. But if the one behind it is 5 or above, like this one, then it tells it to bump up by 1. And there you go. Then once you have them rounded to full numbers, you add or subtract them, and you get your final answer. All right, my little mathematicians, I hope you feel like an expert now on decimals. Congratulations, you got this.